Okay, what's the probability of drawing a red? Okay, so how many red cards are in this deck? Let's just make everything out of 52. How many red cards would you have? Right? We all remember there's 52 cards in the whole thing. How many of them are red? Half of them. What's half of 52? 26. Or, what should we do? What should I do in the math when I see or? Add. Or a face card. How many face cards are in this? I'm just going to keep everything out of the 52. How many face cards do you have in this? You know what face cards are? The jacks, the queens, and the kings, they all have a face. So there's 12 of them. Okay. Were these events overlapping or completely separate? Overlapping. Because what did I do? I ended up counting these red face cards twice. So the red face cards I counted twice. So I'm going to have to minus the overlap. So how many cards did I overlap and count twice? 6. I counted the red face cards in the red and in the face cards, so you double counted them. So now we can work with that. So there's 32 cards out of the 52 that I could pick. Okay, and if you literally just wanted to count individually, right? All these reds I've already marked, and then just those 6 more makes 32. Okay, drawing a 5 from a deck of cards. So how many 5s are in the deck? There's 4 of them. So 4 out of 52. Or, I'm going to add, or getting a 10. So there's 4 of those. Do those overlap or are they independent? Was there anything that overlapped? No, so that's it. There's 8 cards in the deck that would fit that. Either a 5 or a 10. Well, there's 8 of those. Okay, rolling a 1 on a die. So a 1, there's 1 out of, and you should just know a die has 6 sides. And, so now what are we going to do when we hear the word and? Doing something and something together. We need to multiply. And flipping a head on a coin. So 1/2, which makes 1/12. What's the probability that you will flip 4 heads in a row on a coin? Okay, so heads, 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 getting 4 heads. So the probability of each is 1/2, 1/2, 1/2, 1/2, and you're doing all of it, so it's a timesing. You're doing this and this and this and this, so that is 1 over. Did you get 16? Okay, I'm going to pause. Okay. bag of marbles we have, and then it says 8 red, 7 blue, 4 green. What's the probability of drawing 2 red marbles without replacement? Okay, can you give me the total marbles here? Because probability is always out of totals. So we have, what does that come out to be? 19 marbles? Okay, I'm going to go into the bag. What's the chance that I'm going to get a red? 8 out of 19. I do not put it back, so let's pretend I put it into my pocket. Then I go back in, and the second time, now there's only 7. And instead of 19, because I kept one, that turns to an 18. And what math operation should I do when I'm doing this? Add or times? Times. So 56 out of 342. Okay, probabilities, completely just leave them as fractions. That's fine. I don't expect you to reduce them. Like this one I could have reduced. I don't expect that. I'm also okay if you make it a decimal. I'm also okay if you make it a percent. They could go either way. Drawing 2 green marbles, and the first time you put it back. So a green, there's 4 greens out of 19. And I put it back, so it's going to have the same because I put it back. So 16 out of 361. Okay, this one says I want to get 2 of the same color. So tell me about a situation that could occur. I need the same color, so what could I possibly do? I could have done 2 reds. What else? Or 2 blues. Or 2 greens. So we know that we're going to be adding all the situations that could have occurred. Okay, we are not replacing. Are you okay if I just quickly go 1918? Because everything will be the same there. 1918. When you don't replace, the first draw would have had 19 and the second draw has 18. Okay, red. So just going back to the top here, red had 8. And then 7, because you don't replace. Or the other situation. So can you finish this out? Okay, like I said, if you had done it on your calculator and somehow came up with a decimal, I'm good with that too. 0.32 or 32.16%. Okay, I'm going to pause if you want to write anything on your sheet. Okay, when rolling 2 dice, what's the probability of getting a sum? So on these questions, we have to figure out all the possible sums. So I need you to do one of these charts. Okay, I'll give you a minute to fill it in. Okay, so when you're looking at this chart, you have how many sum options altogether. With 6 and 6, that would make 36. And I'm looking for even or divisible by 5. So first of all, let's go through all the even. Or divisible by 5, so I can circle the 5s now. The 10s would be an overlap, so I just don't count them twice. They're already circled. Okay, and then count how many things you've circled. I got 22 out of 36. Okay. I don't know what you want to write on your cheat sheet. Sum of dice. Make sure you do a chart, right? Make sure you do a chart. That needs to be somewhere either remembered or on your cheat sheet. Okay. The chance of getting a good yield on a farm land this year is 70% if you get 2 inches of rain in July. Okay, so we're talking about getting a good crop and rain. So what depends on the other? Does the good crop depend on the rain, or does the rain depend on the crop? Which one depends on the other? The crop depends on if it rains, right? So this can happen after the rain happens. So what's the chance of getting a 2-inch rain? So rain, no rain. So the chance of getting the rain that they need is 65%, which leaves that not happening, what is that? 35. Then you're either going to decide if you have a good crop or not a good crop. So the chance of getting a good yield is 70% if you get the rain. So if you get the rain, 70% good, 30% chance of not good. And then the last part there, the chance of getting a good yield if you're not going to get the rain is a 50 chance. So 50-50. So what's the chance that you'll end up with a good yield? So you need to add this one and this one. So timesing those. So that's a times. And then it's this or this. So those were our times, and then the final is a add, right? 63% chance. Okay, I can guarantee you that one of those is on the test. So make sure you understand. If you want to write something down on your cheat sheet, this is multiply, situation at the end is you adding. Okay, and this event always is dependent on that event. The crop depends on the rain. Okay. The probability of scoring in a soccer game is 2 out of 11. So what does that mean? It means 2 scores out of 11 total. That's how probability works. 2 scores out of 11 total. What are the odds against scoring? So this is when you write something, colon something. The odds against scoring would be not score and then how many scores. So that's against. So you do the not first on the against. So if we scored twice, so that goes there. How many times are you going to not score then? 9. Okay, something needs to go on your cheat sheet about this. These will always add to the total, right? Whatever those 2 numbers are, they will always add to the total possible. Okay, the odds of getting to work on time is 1 to 4. So this means on time, well, this would mean late then, right? This is on time, this is not on time. What's the probability? So probability is something out of total. You're always doing it out of a total. So getting to work on time, so I get to work on time 1 out of, and then what's the total is what I'm looking for. So that's the answer, 1/5. So you will have 2 types of those questions on your test. One where I give you the probability and then you got to work towards the odds, and one time I'm going to give you the odds and then you got to work to a probability. Okay? There is a family lining up for a photo. We have 6 members, which is 2 parents, 4 children. What is the probability that the parents will end up beside each other? So if I put the 6 people and I want to end up with the parents beside each other, what was the strategy? How many units would I move around? Because they are considered 1 unit now. So I'm going to move 5 units around. And then what could the parents do within the unit? They could flip-flop. So this is my event divided by all possible. This is what a probability is. So the event divided all possible events. What is the all possible scenario if you're moving anybody around without any restrictions? 6 factorial. Okay, so that's how the probability of these permutation questions go. Your event divided just by total event, no restrictions. Again, I'm doing these in fractions. Give me a decimal place, that's fine. Give me a percent, that's fine too. 33, if you'd answered 33.33%. Okay, number 8. We have 6 boys and 6 girls on a basketball team. What's the probability that 5 girls would be chosen to be in the starting lineup? So my event divided by all possible events. This is my thinking. So my event is if there was just 5 girls picked. So that would be 6 girls and I would have to choose 5. Technically you don't need this, but 6 boys and I'm picking none of them. That's also happening, but I don't need to put that in because it's irrelevant. I'm picking 5 girls and no boys. Okay, it's irrelevant. You don't need that. Okay, what are the all possible scenarios? If there was no restrictions, I could pick anybody. So that would be 12 people, and I would just pick 5 from anybody. Bless you. Okay, I'm going to pause and see if you want to write something down. You have 120 students in grade 9. The probability that they take music is 50. Probability that they're on sports is 60. The probability that the student doesn't participate in either is 10. So how many students participate in only sports? So this is a what strategy? Venn diagram. So we need one that is music, and we need one that is sports. There's a 50%, a 60%, and a 10%. Which one of those 3 must I start with? 10% is outside. 10% of the people don't even do any of those. What percentage do I need to have inside of the bubbles? The total bubbles need to make what? 90%. I have a 50 plus a 60, which is 110%, which is obviously too much. So what will I put into the overlap? What I have there minus what I should have, which is 20% overlap. So 20% goes in the middle. Okay, so now we go back to the individuals. So music, I need 50% in that bubble. So this would leave me 30%. The sports bubble needs to be 60 altogether, so now that would be 40. Everything that you have in here should always add up to 100. Whatever you've written inside somewhere needs to be 100. So how many students participate in sports only? So this is the sports only, but that's not my answer. I have to say how many students. So what am I going to do? 40% of the 120 students. So what does that make? So 48 students. Okay, I put 2 of those on your test. One is like this, where you would have to start on the outside, and the other style is when I give you the overlap. Okay? So there's two different styles of those where I give you one is start with the outside number, and the second time I give you a question, it's start with the overlap question. Okay, number 10. Actually, I'm going to pause because maybe you want to write something on that cheat sheet. Let's find out what the probability was. So creating a PIN number, so for your bank account, you can use any digit and you can repeat. It's a 4-digit code, and you're allowed to start with 0 on codes, right? So how many possible codes are there for bank account cards? What would you do? We would have 10 digits to pick from. You can repeat. So 10 options, 10 options, 10 options. Which is what? 10,000. So there is going to be a 1 out of 10,000 probability that you and a friend have the same. Okay? If that's hard to think about, I'm going to talk about it a little bit differently here. So basically, you could pick anything. So you would have 10,000 options out of 10,000. And then if your friend wants to have the same, they would only have one option out of the 10,000. And obviously this cancels, and that's how I get it. Okay? But those ones are just a 1 out of. So if you want to have the same or end up with the one possibility, it's a 1 out of. All right, last, you're creating a 3-digit code. And you get to use the digits 1, 2, 3, 4, 5, 6, 7. What's the probability that the code would be divisible by 2? So how do I know if a number is divisible by 2? So this is a math idea that you should just know. How do you know if something is divisible by 2? When you look at a number and you're like, yeah, I know that's divisible by 2. Why? It's even. How do you know if it's even? What makes a number even? You just know. Why? Okay, is 48 even? Is 54 even? Is 67 even? No. Okay, why? Why are these even and not even? Because why? What are you looking at? Because it ends with a even. So I'm worried about it ending. What could I possibly put in that position? A 2 could go there, a 4, or a 6. So there's 3 possibilities to be even. Okay, you've already put one of them there, and you can't repeat. So now how many options would you have in the first digit? 1, 2, 3, 4, 5, 6, 7. There's 7 items. And if you've already placed something there, now you have 6 and then 5. This just means I had 3 options, but I put something there. So I put one thing there. So that's 90. This is my event out of So I still have to do out of all possible events yet. So that's because that's what probability is. So there's 90 even codes. And what would you do if you were making this code with all possibilities? So basically understanding it doesn't have to be even now. So I have all these digits. So it should be 765, right? Because repetition is not allowed, but we're not worrying about it being even anymore. So there's the probability, 90 out of 210. My event, it being even out of all the possible codes. Okay, there's one more style of question that's not on here that you need to be checking out. Something that has at least. What do you want to do? I'm going to flip 4 coins. At least, I want to get at least one of them to be a head. I have 4 coins, I want at least one head. Okay, there's 2 methods that I taught you how to do this. The long one or the short one. Okay? The long one would be the situation where I'd have 1 head, 2 heads, 3 heads, or 4 heads. The short method would be all minus the opposite event. So those are the 2 ways you could do a question like this. So if I was to get 1 head, I'd be doing a head, tail, 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 which is a half chance, a half chance, a half chance, a half chance. But here's the part that's tricky. That's not the only situation I could do. I could go tail, head, tail, tail. I could go tail, tail, head, tail. So I'm going to have to do this. 4 choose 1. I'm going to have to times it because in that situation you're just choosing which one of the 4 flips is the head going to be on. So there was 4 different ways I could do that yet. So that is 4/16. So if I did 2 heads, it would be heads, heads, tails, tails, which, I mean, they're all 1/2. But I would need to put 4 choose 2 in front of it because that's not the only situation. You could have also done head, tail, head, tail. You could do, you know what I mean? There's a bunch of them. There's actually 6 ways you could flip 2 heads, right? So that's 6/16. So if I did 3 heads, 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 tails, it'd be 1/2, 1/2, 1/2, 1/2. But I need to do a 4 choose 3 because there's a bunch of different scenarios. So that is 4/16. And then 4 heads. So this is 1/16 because 4 choose 4, it's irrelevant because you can't change anything around there, right? They're all just heads. You can't change any location of them. So what do we get there? 10, 15 out of 16. So this one would have been way faster for me to do. What's the only other event that's opposite of this? No heads. So I would have flipped tail, 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 right? And you don't have to do a choose in front of it because there's no other arrangement to move around there. They're all just tails. You can't change the location of doing something. So that's 1/16. In probability, what is the all number? When everything happens, what's the probability of it? 1. A probability, if you ever do a full probability, it's a 1. Or in a percent, you can say it's 100%. Or in this case, also a fraction, 16 out of 16. So the full 16 out of 16 minus the opposite event. Do you see that? I got the same answer. So if I'm picking, I'm going to probably be picking this one. Maybe you should write something down. Somewhere along the line, you're going to have a question that's the at least. So you can do the multiple situations or the strategy of opposite event.